Hello, sixth graders. Welcome to 7.3, where we're going to move on in equations and discuss a little bit now how multiplying and dividing work when solving an equation. Okay, so for our key idea today, it says something very similar to what your last key idea did when we were using subtraction or addition. Now it's using multiplication or division. And the thing to remember is when you multiply each side of an equation by the same non-zero number, the two sides remain equal. For example, if you had 8 divided by 4 equals 2, well, you know 8 divided by 4 is 2. If you were to multiply both sides of that equation by 4, 8 over 4 times 4 would give you, multiplying it across, 32 over 4, and 32 divided by 4 would give you 8. And if you did the same thing on the right-hand side of the equation, 2 times 4 is 8. So that remains true. That's what they're saying here is when you remember equations are like scales. I'll keep coming back to that. But whenever you do something to one side of an equation, you have to do it to the other to remain equal. Okay, it works the same here. And notice that they write it as x over 4 like this. Remember, this means dividing. We don't really write it like this anymore, x divided by 4. When you're introduced to algebra, we start writing dividing a lot of times where it looks like it's almost a fraction. Remember, that means dividing. It's just another way of writing it, right? So the same then is true for the multiplication property. The product of a non-zero number, n, and its reciprocal, 1 over n, is 1. So 5 times 1/5 is 1. Let's just make sure we remember that. 5 times 1/5. These are reciprocals. 5 times 1 is 5. 1 times 5 is 5. 5 divided by 5 is 1. That's all that's saying. Okay? Where n cannot equal 0. So main point here is that when you're doing one thing to a side of an equation, whether that's adding, subtracting, multiplying, or dividing, you do it to the other side as well so that your scale remains balanced. All right, let's try a few examples out. Solving equations using multiplication. So it says solve w divided by 4 equals 12. So this is saying what number, when you divide it by 4, will give you 12. Okay, let's remember a few hints about solving one-step equations. Sometimes it's helpful to split your equation into two, like a scale, a left and a right-hand side. And you ask yourself that question, what is being done to your variable, and how can you undo that? Well, in this case, w is being divided by 4. Remember, this is like a division sign as well. So how do you undo dividing by 4? Well, you multiply by 4. And try to use a dot if you can now, because remember, if you're using x's, that looks sometimes like another variable and it can be confusing. So if you can, use a dot, right? On the left-hand side, multiplying by 4 and dividing by 4 are inverse operations. They are going to give you 1. Let me just clarify this, and this is an important idea. If we take 4 over 1 and we multiply it by w over 4, that's what we're doing right here. What would this give us? Well, 4 times w would be 4w over 1 times 4, which would be 4. And we know that anything divided by itself is 1. So this would give us 1w. And remember, 1w is the same as w. That's what we want. We want to isolate our variable so that we just have one of it, right? So essentially, these will cancel because that's going to give us 1w, or we like to abbreviate it as just w, equals, and then you just have to take 12 times 4, which would give you 48. Again, double check that. Put this into the original equation. 48, substituted for w, divided by 4, does that give you 12? Yes, absolutely. All right. The next one, it says solve 2/7 x. So 2/7 x means that we're multiplying 2/7 times x equals 6. How do you undo multiplying by 2/7? You divide by 2/7 on both sides. Divide by 2/7. Remember, split out the equal sign if you need to. 2/7 divided by 2/7, that's just 1. Anything divided by itself is 1, so I'm left with 1x equals, and now, got to think back a few sections. When we divide fractions, we have 6, and 6 as a fraction is the same as 6 over 1, divided by 2/7, right? And remember, we use the acronym KFF when we're dividing fractions. Keep, flip, flop. Keeping the first fraction the same, flipping division to multiplication, and flopping the second fraction to its reciprocal, so 7/2. All right, I'll simplify before I multiply. Looking diagonally, dividing each by 2 would be 1 and 3. And then 3 times 7 is 21. And on the bottom, 1 times 1, that's just 1. So 21 over 1 is the same thing as 21. And you can easily check that. Take 21 times 2/7, and you should come up with 6. Okay. Please pause the video now for the 3 on your own problems and see how you do. All right, here's what I came up with. Here I would multiply both sides by 8. So I would get 8 equals 48. Number 2, it says 2y divided by 5 equals 14. So you can think of this as, well, there's a couple different ways you could do this, but I like to think of this as 2/5 y. So 14 equals 2/5 y. And what I would do is I would divide by 2/5 on both sides, because 2/5 is being multiplied by y. So I would do keep, flip, flop. Keep 14 the same, flip division to multiplication, flop this to its reciprocals, that'd be 5 over 2. Simplify first, so I would get 1 and 7, and then multiply across, which would give me 35 equals y. Okay, and remember, that's the same as y equals 35. Those are the same thing. Okay, it's just different order. And then lastly, for number 3, it says 3z divided by 2 equals 9. Okay, well, in this problem, you might see that, okay, well, there's a couple different things happening to my variable here. It's being divided by 2, and it's also being multiplied by 3, so I need to undo a couple things there. So first, to isolate z, I'm going to get rid of this dividing by 2. How do I undo dividing by 2? Well, I multiply by 2 on both sides. Dividing by 2 and multiplying by 2 would cancel out there, the opposite, and I'd be left with 3z equals, on the right, 9 times 2 is 18. And in my last step, I'd say that, again, I'd ask myself, what's being done to z? Well, it's being multiplied by 3, so to undo that, I would divide by 3 on both sides. So 3 divided by 3 is 1z. And also notice how I put the slash through my z, and the reason being is because if I didn't, it sometimes looks like a 2. So that's why I add the slash there. Equals 18 divided by 3 is 6. Let's just double check that to make sure. Substitute it back into your equation. 3 times z, so 3 times 6 is 18, and 18 divided by 2 is 9. Does 9 equal 9? Yes, it does. So correct. All right. Next key idea, we look at the division property of equality. And it says when you divide each side of an equation by the same non-zero number, the two sides remain equal. So just like all the other properties that we've talked about, when you do something to one side of an equation, do it to both sides. Here you see 8 is being multiplied by 4. So they divided by 4 on both sides, and you get 8 equals 8. No shocker there. Here, 4 is being multiplied by x, so you divide by 4 to undo that on both sides, and you come up with 32 divided by 4 is 8. Right. Example 2 talks about solving an equation using division. All right. It says solve 5b equals 65. Okay. B is being multiplied by 5. To undo that, I would divide by 5 on both sides. 5 divided by 5 is 1. 1b equals 65 divided by 5 would give me 13. Okay. Just undo whatever's being done to your variable. To finish things out for examples, it says the area of the parallelogram shaped courtyard is 2,730 square feet. What is the length of the sidewalk? So let me make this a little more clear. We're looking at this sidewalk right here. We see that it creates a 90-degree angle. So what we need to do is set up our equation for the area of a parallelogram. Well, we know that area equals base times height, or think of it as length times width. And what I'll do is I'll put my knowns into this equation. I know my area is 2730 equals my base, looks like it's 65, times my height, which I don't know, that's the length of the sidewalk. So I'll put in a variable, h, 65 times h. All right. What is being done to my variable now? Well, it's being multiplied by 65. So to undo that, divide by 65 on both sides. Cancels out. And then 2730 divided by 65 will give you 42. And my label would be feet. Sidewalk would be 42 feet long. All right, end today by trying 4, 5, 6, and 7 with on your owns, and then check them to see how you did. Right, number 4 says P times 3 equals 18. In other words, what number times 3 gives you 18? Well, you can probably do a mental math with that one, but again, the opposite of multiplying by 3 would be dividing by 3 on each side, and you'd be left with P equals 6. Number 5, divide by 12 on both sides, because Q is being multiplied by 12. So Q would equal 60 divided by 12 gives you 5. Number 6, 81 equals 9R. R is being multiplied by 9, so to undo that, divide by 9 on both sides, and R equals 9. And lastly, number 7, you and 4 friends buy tickets to a baseball game. The total cost is $70. Write and solve an equation to find the cost of each ticket. All right, so you and 4 friends. So how many total are there? If it's you and 4 friends, that'd be 5 total. We know the total cost is $70. We don't know the cost of each ticket, so let's call that X. 5 of you each buy a ticket at an unknown price, and we know the total is 70. So here's your equation, and to find out how much each of you paid, divide each side by 5 to undo that, and X equals 14, and in this case, it would be $14. All right, if you have any questions on solving equations by dividing and multiplying, let me know. Otherwise, that wraps things up for today. Remember to be kind to one another, and I will see you next time.